Good evening. My name is Charles Gilbertson, and today I will be presenting my project on the recipe classification for certain special diets. On this project for a few reasons. The reason that stood out was popularity of special diets. But it can often be a challenge to find the recipes that meet the needs of such dietary restrictions, which I propose a solution to: text data mining for recipes. From the recipe data that I worked on, each recipe was classified using 4 different binary classifiers as follows. In addition, I also used the following non-binary classifiers for each recipe. Using these different binary as well as non-binary classifiers, I was able to use a text classification with a bag of words approach. When looking at the data for each recipe, I only mostly looked at the ingredients data in my approach. My bag of words approach used a TF-IDF vectorization. Since I wrote code for this project using Python, I was able to use Python's sklearn library as a tool for the implementation of my approach. I had to decide which classifier was able to give the best results in correctly classifying each of the recipes. For these classifiers, which parameters were the most successful? For my approach, I compared the following classifiers. Before the data was able to be classified, several pre-processing steps needed to be performed. I performed the following pre-processing steps after the data was read from the JSON files. In particular, I needed to remove the stop words. The stop words were just words that were irrelevant to my classifications and words that I didn't care about because these words were not food ingredients. However, certain food ingredients were even more important in the classification of the recipe. These such words were given double weights. The data that I downloaded was not labeled, and I needed some form of training data in order to perform recipe classification. Fortunately, my mother volunteered to manually classify almost 1,000 recipes and provided the data for me to use on my recipe classification project. I performed the following experiments for my recipe classification. Based off of these experiments, I found that the top best performing classifiers were as follows. As you can see from these results, no single classifier was the best for all tasks. K-nearest neighbors in particular performed poorly, and it was very difficult to predict the type of dish. With the recipe classification, the days of endlessly searching the web to find a recipe to cook that meets your dietary needs are over. Now, recipes can be instantly classified so you can find the perfect meal to cook without going off of your diet.